Hello everyone, I finally received the new spot welder. This is labeled, as you can see, Bl18-2k. Okay, Bl18-2k. This is has the fixes. This was the one that I had, the original one, which kind of blew up. The Bk11-1k. Main differences are this one. These two boards are practically identical. I'll show you. This is the one that this is an Arduino. It's the one that the code I wrote on Instructables. If you have the blown MCU, you can take an Arduino Pro Mini, 3.3 volts, and just solder the points that I describe in the code, and you're set. It works. I mean, I've been using it for a while, and I must say that this one, well, it's working, and I've soldered 0.1, 0.12 works fine. 0.15 has some difficulty, but that's not the problem of this board. It's just the power, the deliverable power of the setup. As you can see, this is the they're pretty much identical. You see, the resistors are placed in the same position. They have the same exactly the same layout. The only thing is a silk screen. As you can see, the newer version has a silk screen, and here the silk screen has no component layout. You see, there is no I mean, the component layout labels that are missing here. And here, if you check, you can see them. Now, what did I do? I didn't operate it. Okay, the first thing I did was disassemble, open it up, which I suggest everyone does if they receive this version, well, actually any, and check that the solderings. I refluxed all of these SMD resistors. I think they changed some values. I will just double check in a second. 30 ohm resistors are the same because that's what's needed to drive the gate. Because of an impedance, it's 30 ohms, so that's pretty much standard everywhere. And then you have these pull downs, which are 2k. Here, these are 2k. They are responsible for turning off when this turns off, this push-pull here. These are again the two transistors that are in the same identical push-pull configuration as the old one. I will show you. Okay. As you can see, this is the old version. Whoops. Okay. And this is the new one. As you can see, the difference is the top here is missing two resistors. Okay. Those are the resistors that on the old board were bodged on here in the back. Okay. Pin 2, actually pin 4, because pin 1 is a square counting from the top. This is the 1k, 10k. So you have two resistors here. They're both hidden. I removed them because this was the problem that I had basically with this board. It was not making well contact. I explained this already in my first video. So this is the old one, okay? And this is the Bl18-2k new one. And as you can see on the back, there is no more any post-manufacturing bodge, you see? They modified here, I don't know, yeah, here you can see it. These two resistors here, 1 and 2, you see? These are responsible for biasing the base of this transistor. And if you check carefully, you can see that it's exactly coming from the middle here and going there. And this is the input that is coming from pin 4 or from the MCU. Okay, this is the same, exactly the same as the old board. The only thing is that they moved this and they added these two resistors. Now you can check while we're at it, the values for precision. Okay, let me get this. This is tester here. The batteries are nearly dying, but I think it's still visible, basically. Okay, so the bottom resistor here should be 2K, and let me check. Let's see. Yep, 2K. And on the old board, it's 2K. So as I said, that's identical. Nothing's changed. The resistors here on the top, wait, let me show you. These ones here, the ones that they added are exactly the same value, 1K and 10K. And that's the same on the other board. You can check too, but that was the value that, okay. This one's a little bit slow. Yeah, there's a capacitor, so the value is it's not precise. I mean, it's in parallel. And this is the 1K. Yeah, it's a little bit less, but it's actually also stated on the component. If you check, you see 102 on the left, and this one on the right is a 10K. Yeah, it's pretty visible, I think. Yeah. So anyhow, the layout is identical, the components are the same, and I checked, as I said. Now, what I did is I went instead and refluxed these. As you can see, they're nice and shiny because the solderings they're not really done well. They're done in a hurry. There's also like residue of soldering around, so I suggest to check these, reflux them, especially the transistors. There's not many, it won't take long. Just refresh the solderings one side on the other. Don't do both too fast, or you will probably move the SMD component. So that's my first suggestion. And secondly, the MCU board here, I checked with my scope in my lab, and with the original 1K resistor, okay, here you see this is labeled R4, right? Maybe with this is, okay, that one here. The original is a 1K resistor. I checked with the scope and I got around 7 volts. So let's say that the driving voltage is pretty much okay. However, I still went ahead and replaced it with a 500K. I had one, SMD, 470, 560, whatever you find around that value. And now I'm getting definitely 11 volts, okay? So, which I find more safe, let's say, because you're sure that you're driving the gates and saturating them well. I measure the voltage, not here, of course. When I'm talking about 8 volts, 11 volts, I'm measuring them, and this is where also I'll show you exactly here. Okay, this is the emitter, okay? And this goes, if you check here on the top, and drives all of these resistors, which are 30 ohms. And as I said in my previous video, then they go to all the individual gates here. So this one turns on, one turns off. This is the output, either here or there. It doesn't matter. It's just here for convenience. I routed it through this hole, so when I move it around, it doesn't break. That's all. And of course, I will remove this. But when I'm doing my tests, especially with the batteries, and I to check the signal here, I went up to 50-60 milliseconds as with my other one, and the behavior is, I must say, exactly the same. The same power is delivered. It's identical performance. So, well, of course, the driving I mean, if the signal is the same and the FETs are the same. By the way, these are 4, right? Because one blew up and I had to remove them all and resolder them, and these are 5. I noticed actually no big difference. The power, the soldering, the spot power is basically the same. I haven't done many, of course, welds with this yet, because I just received it. I tried on a couple of strips and blew some holes just to try and see what the level was. And yeah, it behaves the same as the other one. So I must say that basically it's identical. It didn't break yet, but I think that, I mean, I checked and the performance and the signal is clean. So I don't know. I've had reports saying that, yeah, people have been doing some welds with this one and it also broke, or they are not welding at all. But I don't know. I haven't encountered this problem. As I said, knowing that the quality is not, I mean, the manufacturing quality is not so great, what I suggest is just redo, if you have a thin point, you know, thin soldering iron, redo these solderings, especially on the driver's side here, on the 30 ohm side, and also very important, the bottom side. Why? Because when it turns off, okay, when the push-pull turns off, the 2K resistors are pulling the gate down, and this is important. I've heard people saying that they've seen, I don't know, one or two of you mentioned that with a scope you saw that if the gate time, the on time was too long based on what you set, which is actually very strange. The only way I can justify that is that one of these resistors here on the bottom is not making well contact, and you should reflux them. Be sure you reflux them, because those are the ones that are going to help pull down the voltage on the gate. And of course, this is the push-pull configuration, so it's very important that this resistor, this resistor here, which is the biasing one, when, you know, one turns on, one turns off, these are important. So just reflux them. These are the critical ones. All these ones here, see these 5 pairs, yeah, these 2, and of course the transistor pins, because this one drives these 2. So okay, if this one doesn't make good contact, then you probably are not going to get anything. But if one of these 2 doesn't turn off properly, then of course you're going to blow your FETs. So just check these solderings. These on the top, well, these 2 here, these are important because, as I said, these are the biasing ones. So basically just reflux these 1, 2, 3, 4, and these contacts here. These aren't really important. These are just for the auto trigger. I actually am using a pedal, and because I mean, it's much more comfortable to spot weld, put the electrodes in a good position, than just press. So I find it a little bit more convenient, and it's a little bit quicker between spot welds. Anyhow, these are the ones, the solderings that you should check. So reflux these and replace R4. See, now it's labeled here on the silver screen, R4, with a 470 or 560 ohm resistor. If you don't have an SMD one, use a normal one and just put it flat here and just bend the legs. Another thing which I forgot to mention, which I noticed on my old board, is this switch. This switch sucks. I noticed that if I would just touch it when it's on, it would just reset. That's not good, because if you are spot welding and you happen to just reset it, I think you know the consequences won't be good, because resetting it, the state of the pins can be not, you know, stay on, stay off. You don't know. It's not good. And this is not backed up by a cap. I mean, if you turn it off, it turns off. So what did I do? I bridged it. It's here. I mean, the switch is not really working. I bypassed it on this one just by getting the power directly from the output. And here, all you have to do is here, just bridge, okay? Bridge these two pins. You solder them, just put a blob of solder here. This will just eliminate the switch. It's really unnecessary. This way, if you connect your spot welder to your battery, it will turn on, no problem. And you don't have to worry about a defective switch. This is also another thing that is, I think, should be eliminated. There is no real need for a switch, because if you turn it off, it's, you know, you still have 12 volts on the board. So the safest thing is just to unplug it. So if you're working with it, you plug it in, and else you just unplug it. Another thing that I've noticed, and I'll show you here, is that they modified the firmware, I think, though I don't really remember what mine original was like. When you turn it on, this turns on in manual mode. It's not in automatic. I can show you, just turn it on here. This is just a regular power supply of my battery, but there's no need. So, see, it turns on immediately. As you can see, the switch doesn't do anything. Wait a second. Okay. Switch doesn't do anything. And as you can see, it's manual mode. You have to put it in auto mode manually, which is safer. So I guess that's a good thing. This is the SMD original resistor, which I just taped on here so I don't lose it. Not a big deal. Then there are the programming headers. Now, just to finish saying about what I did here, replace this resistor, reflux the components under here. Okay, just the voltage that is actually stated here is not really precise. It says 12.7, it's actually 12.4, so it's 4/10 of a volt, you know, out. Not a big deal, but I suggest you check with a voltmeter just to know basically, you know, how far out it is. I mean, everything above 12.5 is good, but at least you know that the calibration can be off. And the resistors are responsible for the voltage divider that gives the voltage here are these here. These two here, this couple here, I don't know if you can see it. You see? R7 and R1, I believe, yeah, these two. And then there is R3, which is just in series, which then goes to the pin that detects the voltage. These two here. So you could, in theory, I don't know, adjust it, change the value slightly, put a pot, but it's not a big deal. This stuff is usually calibrated in code, because every resistor and every converter has a slight calibration to be done, especially these resistors. These are probably 5%, so they're not so precise. With the Arduino version, you can calibrate it yourself, because you can just edit the code and modify the multiplier. In this case, you can't. So I think that's about all I can say here. The only difference, as you can see, I put just some copper stray braid here and just soldered it to just say reduce slightly the resistance here. But to be honest, I didn't see much of a difference with this on or off, so I put one here, and I guess one thing that I did do, which is important, is I fluxed this connector, because when it ships, it has only a soldering on one side, and it's soldered just on the bottom. On the top side, there is no solder practically. So I would suggest you to, you see, I've refluxed this all. Just if you have a good soldering iron, reflux this and do the same here. You see, this side, there's none. This is how they come, and it's only soldered on this side. So I still have to, on the bottom it's soldered, but on the top it's actually missing here. So all the current will probably, I mean, yeah, it's okay, it does work. But here I reflux them both. See, it's completely soldered on the top and on the bottom. Those are my suggestions based on this version, the BL. It's also written here. All right. here, maybe it's, yeah, Bl18-2k. And here, Bk11-1k. Okay, so another thing that I did on here is just taped it, because I noticed that it was getting, I don't know, the components were hitting the cap, and when you're closing it, it's pressing down a little bit, but I didn't see any major, don't see any major problem with this. The one that they sent me here has this, protection here, the coating has been melted. I didn't do this, it came like this, so I don't know, I guess the guy that built it was in a hurry. But it's on the side, so it's not a problem, and there's enough space here, so okay. Now, one thing that I wanted to say regarding the MCU again is it's possible, as I already mentioned, to actually write, let's say, an open source code, like instead of using an Arduino and then having to do all this, because, you know, it's not Atmel 328 little board and solder all this, to reuse this STM. This is an STM8, an F103, and if you get this kind of board, as you can see, the IC is exactly the same. These are very cheap. I think they cost, I don't know, €2 or something. I think I paid it, I don't know, even less if you buy more. The only thing that you have to do here, this can be easily used to develop. It has its own 3.3 volt regulator on it. That's all it has. But you need a programming, USB programming device, which is a little USB converter for this ST MCU. You see, it's an, I don't know if you can, it's STM8. 3, okay, well. And these 4 pins on the side are the ones used to program it. These programming headers are actually already present on this board. You see these pins? There are more because there is also ground and plus. These, it's these 3 here. They are the programming headers on this board. This is the old one, and on this board, they're still here. So why? I mean, I don't find anything really bad with this version, because you turn it on, it's in manual, so it won't auto trigger. Basically, it can be used like this, and I checked the timing is precise like the last one, so nothing to say on the code. It was just that if you want to personalize some other options or maybe change some behavior, you could just rewrite it. It's the library for this OLED is it's known, and also the MCU, so it's not a big deal. If you develop with ST8s, it's, I think, not a big problem once you know what hardware is being used. So, as I said, for me, this board worked, let's say, kind of straight out of the box, but I actually didn't just, you know, I suggest you disassemble it, reflux the components under the cap here, the resistors, the ones that I showed, and replace this R4 here. Now, if you don't replace it, I mean, from what I saw from my scope, it should be okay. I just noticed that with the 500 ohms here, I think it's 510, I noticed a little bit less noise on the start and on the stop. But as I said, everything that is above 8 volts is fine. This was slightly under, now it's 11. It's 11.4, 11.2, so that's more than enough to drive these gates. If you check out the specs, the on of these gates is by specification 5 volts. But the thing is that when you have long lines and noise or whatever, actually circuit is this one here, right? It's always a little bit better to have this more rising voltage, so you're sure that the gate will turn on quicker. That's because it always takes a little bit of time for the gate to saturate and turn on. If you create more voltage, then this, let's say delta V, is traveled faster, and by the time the gate reaches 5 volts, that time has been reduced. So I don't know, it's usually it's better to saturate. It's called gate saturation. These can be driven until 20 volts before you break the gate. So 11 is like 50%. That's fine. I mean, it's okay. Yeah, the only drawback is that they will drain a little bit more current, but that's, I mean, I'm talking about probably microamps, and that's no problem at all for these transistors. It's fine. And by the way, you're turning them on and off, what, 50 milliseconds? That's, the duty cycle is like negligible. So that's no problem whatsoever. Okay, so I will try and do more tests, see. I will use this one, the new one, the BL18. I can't really vouch for any other versions because I haven't actually seen them. The CA, these other versions that have been circulating. I mean, I'm waiting for another 2, which I got from different manufacturers, which have another faceplate, so they're for sure different. The size is the same, but the display is not on the left, it's on the right, and it's written Maple Weld, something like that. And those, I'm sure, have a different board. I mean, like also different driver, but I don't know. You never know these until you receive them, because you know, subject to change without notice. So anyhow, basically this is all that I can say. My recommendations for the welding points are the same. To, you know, like round them off and avoid the sharp, because they arrive and they're very sharp on the edge. And when you're soldering them and you're like 45 degrees, it's only that sharp edge that touches. And usually it's very easy to puncture. If you have like a little bit more of a rounded point, you have to push harder, but the surface is a little bit more, and when it welds well, because that's the point, it's to get it welded, then it has more surface contact and more welding material. It does take more energy though. That I forgot to say. If you have a sharp corner and you weld, you can actually puncture it more easily, so you use less energy or less time, let's say in this case. And here, if you have a bigger surface and you use the same settings with the same battery and everything, you'll see that it's going to take a little bit more time to weld. But when the weld is done, you will notice that it's very hard to rip apart. So, or as I said, it's very you can blow like a hole right through. Don't know, here I blew one here and on the corner. I was trying various settings, and if you don't make good contact, that's what happens. You get a clean hole through, and this is a 0.15. These are this one is a 0.12 and this one is a 0.15. This one is very hard to weld with this. You can, but you have to really press and dig in, you know, and use like, I think 60 or 60 milliseconds. And if you don't press correctly and you don't have a good contact, you will blow a hole through it. So yeah, it takes a little bit more effort, but okay. So I know I keep reading the comments because I'm curious to see if what other people's experience have been with at least these versions. I've seen that some people have had no issues whatsoever. There are people who have been using this mini spot welder, though I don't exactly know the version, without problems, just out of the box. And many others, unfortunately, the first 3 welds, they just blew some fat. As I said, do that stuff before, check it out before doing any welds. Remember to use, if you haven't watched my other videos with recommendations, use an AGM battery. lead acid, but not gel, not those dry gel batteries. Those are not capable of delivering the current necessary for that, that 50 millisecond or less time. And the voltage drops a lot and it overheats. What you do is you increase the time. Then what happens is by increasing the time, you increase the let's say not duty cycle, but the time that the FETs are on. And as the voltage is lower, the current is lower, they actually heat up more, and that's not really good. And if you're not making good contact, it can start sparking and a lot of noise. And I don't know, I think most of the problems are probably due to batteries not being powerful enough. If you have a LiPo, as I said, check and be careful with LiPos, because if you do happen to short one of these out and your electrodes fuse together, it can happen. They can stick. It's gonna be bad. So be careful. And with AGM batteries, it's very hard to get them fused together. And if they do, you can always rip them apart, and the battery doesn't do anything. The battery is just sitting there. It's at max it will start a little bit boiling and dehydrogenating, but it's not going to explode or anything. Never happen. So as I said, these are basically all the recommendations I can make, and I hope people can check and at least do these mods and clean up if you find any bad solderings or anything, which are probably also responsible for some of these problems. The gates usually are soldered well here. There's no, in this version there is no problem on the back. As I said, I just modified that resistor, which I've shown, and basically that's it. I checked the gate and everything looks fine. I will drive it a little bit more and see if it holds. But my battery, I use this small AGM battery. It's 120, 130 cold cranking amps, and it's okay for the time, the 0.12 spot welds. For 0.15, you really need a beefier battery. You really need a bigger battery. And I think, these let's say wires here, they are not really top quality. I think they're tinned inside, and they do tend to, if you feel them after a few welds, you can feel this gets warm, but also this shouldn't really get warm. It means that there is a loss on the cable. So okay, it's cheap, and so probably if you replace the electrodes here with a beefier wire, with a thicker or short, if you shorten these it would be better, but then you can't really, it's not really easy to. You need at least 20 centimeters here. So I think the limitations of these welds is also the cable. And you've probably seen, I think K-Weld does this it's more, let's say, professional kind of a welder, and it's, of course, it's more expensive, but yeah, you get more FETs, you get the calibration routine, which it's something that could be implemented on this version with just some additional modifications, as I already said. But as I said, I don't think it's really necessary for 15, what is a kind of 15 euros or 16 euros, I don't remember. I think the last one I paid a little bit more. It depends on the buyer, on the seller. But for this money, it's fine. Just consider these 5 MOS. If you buy 5 MOSs from Farnell or any other, they cost more than 15 euros. So, it's basically fine. Of course, if you use it 5 times and it blows up, then you're like, what the hell? I prefer spending maybe over 100 euros and getting something more serious. I don't know. I hope that with these modifications, they will last. As I said, it's something that's useful for the hobbyist to make a few spot welds. Certainly not making hundreds of packs a day, because this thing won't. It's going to overheat. Maybe you can switch between 2. Many do that. or just buy a beefier one. But as I said, I like this because of the display. The display circuit I mean, the display setup here, it's interesting because you can have actually some reference. With the ones that don't have a display and you just have the 3 settings, you really don't know how many milliseconds you're doing, and you're saying, yeah, but who cares, you know, the thing is that I just want to spot weld. But with this you can fine tune it much better, especially on the thinner strips, and you can also adapt it to your battery. 3 settings are a little bit big, you know, you have a medium or a large, and usually people are using the maximum setting. But if you have, I mean, there's a limit, and maybe it's okay because at least you can't exaggerate. Because if you go to, I don't know, 90, and you have a bad contact, and then you try welding, this thing will blow a hole somewhere because it's way too much. I mean, I've reached, I think, maximum 65, and that was way too much. As I said, it was. I think this operates with the thin strips between around 20, 25 upwards. From 25 to 35 with a 0.1 millimeter. And if you have like something thicker, with this battery, I'm around the 45 maximum. I don't think I've ever gone over 50 to solder the batteries. As I said, it also depends on your battery, on the losses, on the contacts and everything. Use screw-on contacts or XT contacts. It's very important because I see people using like some cheap alligator clips put on the battery, and no, that's not good. You won't get a strong pulse through that. There are too many losses. It has to be screwed on, or you need to use gold-plated XT contacts for sure. Okay, I think that's about it for now.